So we've got a group of people who are totally focused on the US defense industry. So I'm going to talk about how our products fit there, what Freescale brings to that market, what our product offering is today, together with not just product but engineering resources and enablement to enable that customer base, and the recent improvements in our LDMOS performance. So we've announced this today. We're offering all our current commercial products because they meet a lot of the military applications. And we have LDMOS, we've got our gallium arsenide products, and we also announced this afternoon our first GaN device. So we're bringing a big technology base. We have a big application support group. The products that we bring with the military group, we will offer 15 years longevity guarantee to customers, which is important for this customer base. We're not going to make the parts obsolete after a very short time. And the products enable swap, size, weight and power reductions, both in plastic packaging and also our air-fast technology performance improvements. So we come from being #1 in the world in RF cellular products. We also have a big, strong presence in ISM, land mobile, broadcast communications, and now we're going to bring those strengths to the US defense industry. Offer our COTS portfolio, customer support applications, and also ITAR compliance, so we can handle ITAR communications. We have the broadest LDMOS portfolio in the industry, more than twice the number of products as our nearest competitor. The highest performing LDMOS available in the market, and also I think the other strength we bring is product packaging, both ceramic and plastic. We're the only large US fab of LDMOS. Our competition manufactures overseas. We have our own internal dedicated package manufacturing and assembly and test. Longevity program I mentioned, 15 years. All those other things. So this I think really shows where we fit today in this marketplace. From low power UAV sort of drone applications through communication radios, radar applications, which is big in the military, both over the horizon, VHF sort of type frequencies, and also L-band and S-band radars, and also broadband jammer equipment. So as you can see across the bottom there, there's sort of frequency bands operating in LDMOS up to over 3 gigahertz. This shows our power level up on the vertical scale and across frequency across the horizontal scale. So you can see we've got devices up to 1.25 kilowatts. One of the highest power products on the market, and multiple hundreds of watts right across the whole frequency bands there. We don't just bring the devices and the device technology. We bring packaging technology, plastic packaging particularly is a strength. The performance of plastic packaging is actually better than the ceramic packaging. Surprises a lot of people. You actually get better thermal performance. It's because of the heat sink isn't a copper alloy, it's solid copper, and then also you get heat taken away from the device by the encapsulated plastic. Takes actually heat away from the wire bonds. So you actually get better thermal performance. Manufacturing, we have our own internal manufacturing site which reports directly into our business, not to a separate manufacturing business. Applications and systems support. We have applications engineers, systems engineers with a wide range of experience. We offer test fixtures and reference designs. We have over 130 available reference designs with all the drawings to help you replicate the design for your own manufacturing if you wish to do that. Behavioural models we support, and thermal characterisation. So we can look down to very low spot size on the devices, looking at the die or the wire bonding if there are heat issues. This shows our rugged portfolio devices. We introduced about 12 months ago devices which are guaranteed to work up to 65 to 1 DSWR. So that's like 97% reflected power back into the device. These were designed for like laser amplifiers in very bad load conditions, which I think is very also applicable to military applications where you can have a co-located antenna that's broadcasting at high power, and that comes back down to the antenna of the device you're operating from, or the antenna can actually get blown off in an application. So I think it's very applicable to military applications. Then if you look at our latest technology we introduced last year, at the end of last year, it's our air-fast technology. We actually took a leapfrogging performance of our VMOS. We increased the drain efficiency from 5% by 5%. We increased the power density on the die by 25%. We're similar improvement in linearity and instantaneous bandwidth up to 150 megahertz, very broad bandwidth for LDMS, as well as improving the plastic packaging that we have today. And somebody think, well, what does that mean to a customer? Well, this is what it means to a customer. We had a customer using 3 devices to make a 600 watt amplifier, 50 dBs gain. He was able to go from 3 ceramic devices down to 2 plastic devices. So he had a cost saving in actual devices, but he had a 50% cost size reduction of the amplifier. So that fits into that size, weight and power reduction sort of requirement for military applications. Plastic packaging. This is somewhere we lead in RF power. We've got high power ceramic parts up in the top left hand corner, lower power TA packages, and then lower power parts across the bottom, except for these. If you look at these two, these are high power plastic packages, and the 2 devices in the opposite corners are actually drop-in. So if you designed the ceramic part in the top left hand corner, this part's a direct drop-in, lower cost, lower weight, better thermal performance, better mechanical performance actually, because the tolerances on the plastic packages are tighter than ceramic packages. So that helps improve performance as well. This is just sort of a fun slide. If you look at, we've been in the LDMOS business since 1990. We were the first people to bring RF LDMOS to the market. If you add up all the LDMOS parts that we've shipped to date, it adds up to more than 5 billion watts of power. We've shipped more than 175 million power plastic packages. We ship more than 30 million a year. And if you make a cell phone call today anywhere in the world, there's a 60% chance it's powered by a Freescale transistor in the base station. We have more than 400 RF products available today, and we're adding more than 50 this year. In fact, we announced 33 new LDMOS devices today at RMS. So it's not just the devices, there's also application support that we give. So this is just an example of an S-band pallet. The fixture at the top, the larger one, the 4x5 inch one, is our standard test fixture for the device and would be the normal sort of application circuit we might give a customer. We had a customer that required a much smaller footprint, so we actually developed a 2x3 inch pallet. In fact, if you come to the Freescale booth, we can show you that. We can supply the transistor, or we can supply the fully manufactured pallet for S-band radar applications. That's a 330 watt L50 LV device. This is another broadband application for RDMOS. This is a 100 watt push-pull device. It works from 30 megahertz to 512 broadband application. We're also developing a 400 megahertz to 1 gigahertz test circuit for this device as well, which should be available on our website very shortly. We also have a growing portfolio of gallium arsenide MMICs. This just is a highlight of parts. These are GPAs in the top left-hand corner. They work from up to 50 dBm IP3 and up to like 2 watts output compression point. We also have linear amplifiers. These are sort of 3 to 5 volt supply devices. These are all two gain stages. So the gain is about 27 to 30 dBs. The output P1 compression points of up to 2 watts. So what's the whole picture that Freescale can offer the customer? So there isn't just the technical support, the circuit tuning, modeling, thermal characterization, reference designs. We also have a lot of experience in digital pre-distortion, Doherty configurations, drain modulation, switching PAs. We have a lot of innovation in our history, with more to come. And also we have a very secure, I think, supply chain, with large volume supply and manufacturing, and a lot of quality data behind us. We come back to the plastic packaging. People think that it isn't, this ceramic and plastic. Ceramic should be better. We've got a lot of data now of use in cellular base stations, which is a very difficult environment to work in, because they work in places like Alaska, they work in Arizona in the desert in high temperatures, but they also get a lot of thermal cycling from being used all day when the devices are very hot, and then they go cold at night because people aren't making cell phone calls. So it's a very thermally challenging application for RF power devices. So what does the future look like? It's higher power. The highest power part today is 1,250 watts. You'll see higher power parts coming, higher frequencies, particularly I think from our GaN portfolio, which we just started today. You'll see much higher power and higher frequencies from us. So we have a history of firsts in RF power, and I think you're going to see a lot more from us. So thank you very much for listening. If you've got any questions, I'll stay here now, or come to the Freescale booth and we can talk further if you've got particular questions.